Hello everyone, today we are going to discuss the fifth problem of AtCoder beginner contest 335, which is non-decreasing colorful path. So what is the problem statement? We are given a connected unrelated graph with n vertices and m edges. The ith edge is between ui and vi bidirectionally. One important thing, each vertex has an integer written in it. Let's consider this as av. Now what we have to do, for we have to find the highest score among all simple paths from 1 to n. So what is a score? What is a score? The score means that we have to take some non decreasing path, simple path from 1 to n, and we have to maximize the score. So let's take one example. Let's take the first example only. So what is the graph? We have 1 to 2. What is the 1 to 2, 1 to 3, 1 to 2. Let me draw this. So I have drawn the graph. So these edges are bidirectional, and the green values determines the value present at node I. So one has a value 10, similarly 2 has value 20, like that. So we have to determine the longest path with unique values which is non-decreasing. So let's take some path. So we can take this 10 to 30, 30 to 40, and 40 to 50. This is one possible path. Now the second path could be 10 to 30 and 30 to 50, and one path could be 10 to 20 and 20 to 50. So there are three paths. The first path has four distinct values: 10, 30, 40 and 50, which is also increasing. So first path has score 4. The second path has score 2, and the third path has also score 2. So our maximum score is 4. So our answer will be what? Our answer will be 4. Now here every value is distinct, so you might get confused. So let's take some other example also. Now let's consider this example. And now for this example, you can see the first path could be this, like from 1 to 4 to and 4 to 5, but the path has to be non-decreasing. Now 10 to 10 is greater than 5, so we can't take the age from 1 to 4 because it will become decreasing. So we have to take this path 10 to 10, 1 to 2, 2 to 3 and 3 to 5. So what is the number of different integers present in this path? The number of different integers present in the path is what? 10 and 20. So our answer will be 2. So now let's jump into some possible solutions. So the one possible solution you can think of is that doing some kind of depth first search, right? So what do you store? What do you store? So let's say we have some value of DFS of I. Okay, so DFS of I, and we will go to each and every child node of I. And what is the condition? Now we will only go to we will only go from I to j if Vj is greater than equals to Vi. Okay, so this is one condition, that if Vj is greater than equals to Vi, we can go to j. Okay, now what now we will also take some value, like let's say dpy value. Dpi will determine what is the maximum. Dpi will determine, let me write it in text format, that what is the maximum score from I to n, right? So dpi is nothing but maximum score from I to n, right? So how we are determining dpi? By doing this dfs, right? Now let's say we are at some index I, and we are jumping to some node j. Now we already know the dpj value, right? Now if value of I, or you can say a of I, but in my code I have used vi, so I am using bj in my vj in my explanation also. Now if vi is equals to vj, then what? Then our dpi value, dpi will be dpj, right? Because let's say for this example only, the dp of 5, maximum score from 5 to 5 will be what? 1. Now maximum score from 3 to 5 will be what? 10 and 20, two different nodes. So answer will be 2 here. But when we are considering the age between 2 and 3, the value of I, which is value of 2 and value of 3, value of I equals to value of 2, so the dpi will be nothing but dp of j. But if vi not equals to vj for the age between 3 to 5, 10 is not equals to 20, so dp of I will be nothing but dp of j plus 1, dp of j plus 1. Okay, let me clear all these things and try to explain. So you got the transitions now from if I vi equals to vj, we will do dp of I equals to dp of j, and if vi not equals to vj, we will do dpi equals to dpj plus 1. So now let me show you my code. Okay, so here I am initializing v's of I equals to 1. Now if I equals to n, we are doing dp of I equals to 1, else dpi is equals to negative infinity. So why we are doing this case? Let's say we have something like that 1 2 and 1 5 1 3 and 4. Okay, so 1 2 1 3 and 4. So dp of 2 will be nothing but negative infinity, because we can't reach 4 from 2. Okay, we are considering the age if vi is greater than equals to vj. So 2 will be infinity minus infinity. Now this will be 1, this will be 2, and this will be 3, the dp values, right? So that's why that's what we are doing here. If dp I equals to n, or dpi value will be 1, else it will be negative infinity. Now we are iterating over every adjacent node of I. AI will consider the adjacency list. Now if visited of j equals to 0, that means the node is not visited, and vj greater than equals to v of I, we are doing dfs of j, right? We are doing dfs of j. Now after the dfs is done, we have already updated the value of dpj. So now we are doing dp of I equals to dp of I, maximum dp of I comma dpj plus vj not equals to vi. So this condition, these two conditions that are merged together. So if vi not equals to vj, then we are doing dpi equals to dpj plus 1, else it will be dpj. So this is the dfs, and we are calling dfs of 1. And if it is if the dp1 value is less than 0, because we are marking negative infinity also, then we are taking maximum dp1 comma 0, and the n we are printing dp1. But this solution is wrong. Why? So I will give one more edge case to you to determine that this solution is wrong. Okay, so let me write the test case also. Now this is the edge case that I am mentioning. So why our solution will give us wrong answer here? Because so when we are doing DFS, we'll update the value of 3 using 10. So let's say our DP 10 will be what? Our DP 10 will be 1. Now DP of 3 will be what? DP of 3 will be 2. And uh, what will be dp of 2 value? Dp of 2 value will be 3, and dp of 1 value will be 4. But here you can see that the value of 4 5 and 6 are not getting updated in this dfs. In this dfs, when we are doing dfs from 1 to 2, 2 to 3, and 3 to 10, we are also doing dfs from 3 to 4, 4 to 5, and 5 to 6. Also we are marking that 4 5 6 nodes as visited, but the dp values of this 4 5 and 6 will be nothing but negative infinity, right? Because they will not know that we have visited 10 using 3. Because we are just iterating from 3 to 10 first, and doing the iteration of 3 to 4, 3 to 5, 3 to 6 at the second. Okay, so the value of 4 5 6 is negative infinity. So when we are going in this path, 1 to 7, 7 to 8, 8 to 9, 9 to 6, we will see that the 6 node is visited, but the value of the 6 node is negative infinity, right? So the we will not get the correct value. Our answer will be 4 here. Instead of that, the answer should be 1 2 in this path. The answer will be 1 2 3 4 5 and 6. The answer should be 6, but instead for our wrong algorithm, our answer is 4 here. So how we can correct this algorithm, I will discuss later. I will discuss now, obviously, not later. So let's discuss this. So for solving this, let me clear all these things first. So in our previous test case, what was causing problem is that we are having some similar value nodes. So the our graph should be a directed acyclic graph, but instead of that, let's say if vi greater than vj, then we can only go in one direction from 1 to 2. 2 to 3 if this greater than condition is satisfied, right? Vj greater than vi, that is much better. If vj greater than vi, then the directed acyclic graph condition is satisfied, right? But now if something vj equals to vi, then the edge becomes directional, bidirectional, because we can iterate from 1 to 6 and 6 to 5, and similarly we can iterate from 5 to 6 and 6 to 1. So instead of that, let us merge all these nodes with similar values and which are connected. So what will we do? Let's take our previous example now. Once our previous example was like something like that: 1 2 3 4 5 6, and here 3 is connected to 10 and 1 is connected to 7, 8 and 9. So now these four nodes, 3 4 5 6, have same values. So if we can make them a same node, so if we can change this graph to something like that, 1 2, or you can say is merge node. Now it will be 7 8 9. Now all the nodes which are connected to one of these nodes in the what you can say group will have edge to the same. So 9 will have this edge to m. Similarly 10 will have a edge from m. Now if we solve the problem, our solution will become quite straightforward. Our previous algorithm which we are using will become correct, because we will not have this problem of bidirectional edges here, because all the edges will be one directional, you can say, or unidirectional. So let's jump into the correct solution. So this is the correct solution. So now we are taking some DSU. So DSU will be used to merge the connected nodes with similar value or with same value, right? So here in the part, if Vx equals to Vi, we are uniting the X set and Y set, right? Now what is the change we have done done for the in the DFS? So in the DFS, instead of updating the value of DPI, we are updating the value of component of I, you can say. So component of I will be nothing but find the set of I. So we are changing the value of component of I. Similarly, we are changing using the value of component of J instead of DP of J, and the rest of the part is similar. So how we have changed our wrong solution to correct solution, just using the merge technique, you can see. I hope you found this video helpful. If you have any doubt in any part of the video, you can always write in the comment section. I will provide the link of the correct code and the wrong code in the description box also. You may look at that. If you find this video helpful, please like the video and subscribe to my channel. Thank you.